Good morning, everyone. I hope we're all here at the right place. How's everybody doing today? You all got your coffee, you're wide awake, ready to go? All right, you're at your halfway point through Ignite. I'm Greg Kazanza. I'm program manager on the networking team in the OS division in Microsoft. And today we're going to be talking about seamless connectivity to Azure with Windows Server and hybrid networking. So this session is going to be in the context of Windows Server. There are lots of ways to connect to Azure using lots of different third-party appliances, different operating systems. But this is going to be focusing on using Windows Server to do that. Today's a special day, though, for me, not just because I get to present to all of you. That's always special, being able to talk to a lot of people interested in this technology. But today marks my 10-year anniversary at Microsoft. Yeah, thank you. So it was on this day in 2009, when I was at the new employee orientation. I thought it would be good to look back at Microsoft in 2009 to look at, how far have we come in these last 10 years. Now, you probably remember him. It was under his leadership that we got Azure started. It was actually the following year that it went into production. He was the driving force behind a lot of the technologies that we're using today. Some of the product launches that we had back then, some cutting-edge technology, Windows Mobile 6.5, Zune HD, you guys remember those? And then, of course, operating system launches. Windows Server 2008 R2 alongside with Windows 7. You can't forget this, literally because many of you are running this today. And of course, of all these things that I'm showing here, Windows Server 2008 R2 is the one thing that's still in production, running, supported, and that you deal with every day. But even that's coming to an end, right? You're probably all aware that next year, Server 2008 R2 going end of life, unless you can migrate it into Azure, where you get an extension on support. So my theme for today is going to be all about how do you migrate these 2008 R2 servers into Azure. They have a lot of legacy connections, hard-coded dependencies on IP addresses that makes it really difficult to get into Azure. So I'm going to talk about that today. Along the way, I'll show you how to enable your connections so that you'll enable all your other servers to connect as well, or client machines, using Windows Server to enable this. So let's get on our way. Talked about this. You have hard-code dependencies, IP addresses that are fixed. So if you move something in today into Azure, generally it goes onto a new subnet. You either have to redeploy it on that subnet, or reconnect it, re-IP it with a new IP. What we're going to talk about is the first step of how do you actually establish that hybrid connectivity. How do you connect your on-premises network into Azure using one of the connection types that Azure supports. We'll go through all those steps. That'll be the first half of this session. And then the second half is going to focus on getting those machines that you can't re-IP into Azure. So I'll show you how to extend your on-premises subnets into Azure. There are lots of caveats along the way that I'll point out that you have to be aware of. So we'll cover those so you'll know when it'll work and when it won't be appropriate for your situation. That'll be the second half of this session. All right, so let's start. I'm going to focus on these diagrams, kind of building up, starting out with what your network looks like, right? It's going to be something similar to what you see here. You're going to have on-premises, you're going to have an address space. In this example, it's 10.0/16. You'll have some clients out there on part of the network. You'll generally have one or more subnets where your actual applications, your servers may be connected. And that's kind of what your network looks like. You'll have an edge device. This will typically be your firewall, your router, your NAT that connects you to your internet connection. Maybe it'll connect you to your ISP with some sort of high-speed connection. But it's providing these functions to not just NAT your private address space to the outside world, but to also protect protect you from incoming connections. You're going to start in Azure. You're going to create something very similar. It's going to look very much the same way. You're going to have a virtual network router in the middle that's going to connect to one or more subnets. On that subnet, you're going to have its own private address space that's going to be ideally not overlapping with your on-premises, because as you start to create these hybrid connections, you need to make sure that the routing that's going to take place has a single direction that it can go in initially. And so you're going to add a virtual gateway to this network to give it that hybrid connectivity. That virtual gateway is going to be connected to its own gateway subnet. Azure needs that for routing. And that's going to be your connection to your on-premises network. Now, there are a number of different ways you can configure this virtual gateway, and that's how we're going to spend a lot of this session is showing how you can configure that. in the context of Windows Server. So let's go through these options. What do you have? Well, first, point to site. You can configure that virtual network gateway to allow individual machines on the outside world, whether they're in your corporate network or elsewhere, to be able to connect directly to that virtual gateway. And then it'll get an IP on there, and it'll be almost as if it's on the Azure Virtual Network itself. Now, you have to do this for each machine that you want to connect in. It doesn't give you, what we'll then call site-to-site connectivity, which is where you have now an appliance that's sitting on the edge of your network, and maybe that edge router of yours that is now connecting to Azure to that same virtual gateway. But now it gives connectivity to everything sitting behind that appliance. Whether it's a Windows machine, a Linux machine, they can all connect in, and they don't have to establish their own VPN. And so that's what site-to-site gives you. Now, you also have the option of ExpressRoute. ExpressRoute gives you that high-speed connection, dedicated connection through a connectivity provider. I'm not going to talk about this really much more than that in this session, because there's really no role that Windows Server plays in setting that up. Of course, you can use ExpressRoute to connect Windows servers that are on premises into Azure, but Windows Server itself is not playing a role in establishing that connection. And then finally, if the virtual gateway in Azure doesn't meet your needs, you also have the option of deploying a virtual appliance in Azure that provides third-party technologies that can give you, a much different set of capabilities as you connect in. I'll talk about that one a little as well. So let's start drilling into these. Let's drill into point-to-site first to go into a little more detail on that. Now, Windows Server provides, before we get there, so point-to-site, you're going to start with your diagram as I showed before, and you're going to configure that edge gateway for point-to-site connectivity. It's one of the options in the Azure portal that you can say enable point-to-site, and you're going to give it that subnet. In this case, it's 10.3.0.0/24. That's going to be used to allocate addresses to the client that's going to connect in, and then that address will be almost as if it's a virtual network address that machine can directly talk to. Windows Server provides, of course, a VPN client. It provides both IKV2 and SSTP VPN clients in box in full server. Server core does not have the VPN client built in, so you don't have that out-of-the-box capability with server core. But OpenVPN, which is now supported in Azure, does have a client that you can install into Windows Server that will give you that point-to-site connectivity from server. We also launched last year at Ignite something called Azure Network Adapter. This is an extension in Windows Admin Center that makes it really easy to connect your Windows Server into Azure. You don't need to know anything about certificates, networking. You don't even need to start with your virtual gateway in Azure. The Azure Network Adapter will set up everything for you. So let's do a quick demo of what that looks like. So this is Windows Admin Center. And if you scroll down, you'll find Azure Network Adapter under the network node in there. You click on that. It'll refresh in the network adapters. But you'll see the Add Azure Network Adapter button up top. Once it refreshes the adapters, we can go in and click on it. And this will launch the wizard that will connect you in. If you haven't established your Azure connection yet, or your credentials that would prompt you for that, we've already done that, so it didn't. And now you drill in directly through Windows Admin Center and select your region, your subscription, your virtual network information. If you haven't created your gateway already, you enter in the gateway subnet here, which type of gateway you do want to create, and how do you want to handle certificates. This will go in and configure everything for you then behind the scenes. It'll take a little while, especially if you haven't created that virtual gateway in Azure yet. It can take up to 30 minutes to create that gateway. It'll give you progress along the way, letting you know how long it'll take. In this case, it'll take roughly 10 minutes because I've already created the gateway, but it still has to set up the connections. We aren't going to wait those 10 minutes, though. We'll cut ahead. 10 minutes later, the process will finish. And you'll see here now you have the connection. It automatically connects. It keeps that connection persistent, so even if you log out, you're still connected, so your server applications can connect in. We'll do an IP config. You'll see we have that 10.3.0.2 address on the bottom. That is now essentially our virtual network address. And we can SSH using the Inbox 2019 SSH client to connect into a Linux machine running in Azure. We'll go ahead and log in. We're directly connecting now. That 10.1 subnet is part of the Azure address space. And there we go. We have a Linux prompt. We'll do an ls just to show that it's alive. And you can tell this is actually an Azure machine by the kernel version there up top. That is an Azure x86-64 machine. So that's it. That's how easy it is to connect. I mean, it literally took me, including the 10 minutes that I edited out, about 15 minutes to set up this point-to-site connection. I have no dependency on anything configured in the physical network other than allowing that IKE-v2 connection out, which generally networks allow. But that gives you, that single server connectivity to Azure. And of course, that connection can go the other way too. Now your Azure machines can connect back to this server. So you have both, bidirectional connectivity. The main thing about point-to-site, though, that you'll probably want to remember, is that the connection gets established always from the client side. So it's the responsibility of the client to connect into Azure and maintain that persistence. If it doesn't maintain that persistence, then Azure won't be able to connect back out. So that's Azure Network Adapter. Showed you how to find it, showed you how to set it up, and I showed the result of how it worked. All right, so if you do need that bidirectional, many-to-many connectivity, you have site-to-site. It'll use the same virtual gateway that you use for point-to-site. In fact, you can have both types of connections going into the gateway at once. But how you connect in is very different, right? Instead of each machine being set up, you'll typically use your edge appliance. That can be any third-party device that's supported by Azure. It can be Windows Server. The RAS role in Windows Server, of course, can connect you into Azure as well. You can put it on the edge. Azure has lots of documentation. I'm not going to go into detail on how you connect the single server Windows Server in. But essentially, once you have that connection up, those gateways at each end, whether it's on-prem in Azure, will have routes that point to the other side. So if you look on the left side, I've got my laser pointer here. Yep. On the left side, you'll have a route that says 10.1. You're going to go across the VPN connection to get to Azure. On the other side, you have 10.0. It's going to point back to your on-premises address space. And so that's how Azure knows to get to the other side. This is important. This is why you can't have the same subnet on both sides, because they would both point at each other and nobody would know how to get to any individual address on that subnet. Now, another interesting way that you can use Windows Server is by using it as part of your SDN deployment on premises as well. By doing this, you can actually tunnel your VPN connection from an internal virtual network in your on-premises deployment. It can be an Azure Stack HCI deployment. It can be anything that you have that's running Windows Server with SDN deployed on it. And you can connect directly from that virtual network into your Azure Virtual Gateway. You just have to make sure that that IP address that that virtual gateway has is routed all the way up as an internet routable address to your edge appliance that's on your physical edge if your SDN gateway isn't there. One of the new things that we've built into Windows Admin Center that we're launching this week is a new site-to-site experience for SDN so that you can connect directly from your SDN virtual network into Azure in much of the same way as we just showed you with the point-to-site VPN connection with Azure Network Adapter. I'm going to show you that right now. Let's do a quick demo of what the site-to-site to Azure wizard looks like. So here we are in our SDN deployment. If you haven't looked at it in a while, there's a lot of new things in here. We have virtual networking. All the SDN capabilities are now available. Of course, you can create gateway connection types. We have all the, the connections for IPsec, GRE, layer 3. They can all be used, mixed and matched. And if you're going through this direction, you get all those detailed connections about IPsec, all those complicated parameters. If you're connecting to Azure, though, you can use the new site-to-site VPN to Azure. And this, it will look very familiar to that other demo. You drill into your subscription. You select which region, which virtual network. It'll detect if you've set up the gateway in Azure already. It'll then ask you for the SDN virtual network side on premises. What are your properties for that? Your basic connection parameters for that. How much throughput do you want to allow through this tunnel? Because you can have multiple virtual networks sharing the same gateway appliance on premises. We want to make sure they have bandwidth allocated fairly. You'll enter your shared secret, and then this will go and configure the Azure side of the connection with all the right parameters. It'll configure your on-premises side of the connection with all the right parameters. No tweaking, no reviewing IKE logs to figure out why your handshake didn't work. This will go in and configure everything for you in just the right way so that it will work right away. When it's finished, it'll come up, it'll be connected, and you'll be able to immediately have your VMs in your on-premises virtual network talking to your VMs in your Azure virtual network. So that's the site-to-site to Azure VPN wizard that's now in Admin Center. So I encourage you to try it out. Deploy SDN. We're also making that easier to deploy as well with some new deployment wizards as well in Admin Center. It's easier than ever to get SDN up and running, and it can help you establish your connectivity. You can also use that virtual gateway to route to your physical networks as well. So you can actually route through that site-to-site connection to your on-premises physical VLANs also. So that's another way of using that gateway. So I just showed you how to use that new wizard. I want to talk a little bit about a couple other things. First of all, highly available configurations, right? These diagrams actually came from the Azure documentation. It shows the different ways you can configure the Azure side for high availability as well as on-premises. By default, Azure will deploy one gateway, and if it fails for some reason, it'll start up again on a different machine. They consider that active standby. You can also configure Azure for highly available, in which case you actually get 2 gateway VMs up and running. That's the top right corner. And then your on-premises can establish connections to both of those. You also have the option of deploying 2 gateways on-premises as well, and then connecting those into whatever you have for your Azure configuration. That's the bottom row. When you're using SDN, you're going to be using one of the 2 top configurations. The reason for that is because SDN, we have the high availability essentially built in as part of SDN. If that gateway dies, we'll move that connection over to another gateway appliance. You essentially get an active standby mode of operation for SDN. And you'll only connect then make that one essentially virtual connection connect into Azure. You can connect to your 2 Azure gateways if you want to, but that's your SDN way you'll configure your SDN connections to get high availability into Azure. Now, when you start to have multiple connections into Azure, then it becomes important that you have ways of dynamically updating your routes. Because if one of those connections goes down, the gateway has to know, and the rest of your network essentially has to know, OK, I can't use that path anymore. I have to use another path. And BGP is ideally suited for doing that. It has a keep alive mechanism where the 2 BGP peers, which would generally be your 2 gateway endpoints, will talk to each other. They'll constantly ping back and forth to ask, are you alive? Are you alive? If you run Wireshark, you'll see these keep alives going constantly. And they'll detect if a connection goes down. If it does, then it'll update the routing table on that gateway, and however far you let BGP go into your network, it'll update the routing table so that they know how to get across the active connection. So that's really the best way to use those 2 active connections. Of course, Azure supports BGP from their virtual network. Windows Server SDN supports BGP as well as RAS. And of course, most third-party appliances support BGP as well. But it's really cool for handling those failover cases. The really interesting case for using BGP for failover as well is for what's called transit routing. If you look at that bottom diagram, you actually have multiple sites that are all interconnected, each with their own path to each other. The thing is, what happens if that connection down here between the 2 sites, that one right in the middle there, if that one goes down, right, you still want east and west to be able to talk to each other. Well, with transit routing and BGP, because the routes will get updated, that they'll know that those connections are no longer available, it will then go and use the connection through central US to go and get to the other side. This will be true also if you're connected to 2 on-premises connections. BGP and SDN on-premises supports transit routing as well. So you can use that as a way to essentially have some resiliency in your connections, even if there's some external major way that these connections have been unable to establish themselves. So I'm not going to go into detail on how to set up BGP. There's lots of documentation online. But it's something you should definitely look into when you start to have multiple connections to multiple places. All right, that's site-to-site. Quick overview of that. Mentioned before, I'm going to skip over ExpressRoute because Windows Server doesn't play a role. There's lots of documentation on Azure on how to set that up. I'm just going to talk for a minute about using a virtual appliance, though. Because you can deploy Windows Server as a virtual appliance, and essentially that's how we're going to do the extension of the network in a few minutes, is using it as a virtual appliance. Most of the time when you deploy as a virtual appliance, though, you're going to deploying it into your virtual network. You'll pick some appliance out of the Azure gallery, You'll deploy it. It'll get a public IP, and then that public IP will connect from your on-premises directly to that appliance. You don't necessarily need to use the Azure Virtual Gateway in this case. You can if there's a reason to. But this virtual appliance can now provide the connectivity into your virtual network directly. And so that gives you a wealth of partner technologies that are available that can be used both on-premises and in Azure. All right, so these are all the connection methods that Azure natively supports. Now, what do all these have in common? Have you been paying attention? Anybody want to take a guess? They all work at layer 3, right? So you have to have unique subnets at each side, right? There's routing that takes place. Now, what happens, though, when you want to move your workload, right? You want to move that VM, in this case, this VM16. I put it on a 192 subnet because my demo is tied to 192 later on. This 192 subnet, I want to move this VM into Azure, but that VM06, it might have a hard-coded reference to that 192.168.1.250 IP address. If I move that VM over there and give it a new IP, that application is going to break. Same thing, I may have a client out there. Who knows where that client is these days? But it's connecting in, it's mission critical, it's depending on that VM being reachable wherever it is. But it may be running 2008 R2, and you need to be able to keep it alive for a little longer while you figure out these challenges of getting all these clients updated somewhere out there. Now, what if you could create the same subnet in Azure so that you could move it over? Well, with the routing the way it works today, I mentioned it before, you have the 10.0 and the 10.1 pointing across. The virtual network, if you have the same subnet on both sides, the virtual network on each side would just point all the traffic destined for 192.168 down to the bottom there, and it would never go across the tunnel. So you certainly could do what you have here today. You could put that 250 VM there. All the machines on the Azure side would be able to connect to it. They wouldn't connect to the .4 address, of course, because it's on the other side. Vice versa as well. All your on-premise machines wouldn't be able to find that 250 anymore. So that's why we're introducing something this week called Azure Extended Network. It's in preview, and it's now available, fully available. So we have an extension in Admin Center. I'm going to show you how to find it. There's an agent that you'll download and install that is also now available. And you're going to use this, and this will let you extend that on-premises network subnet into Azure. Now, as I mentioned, there are lots of caveats. We'll talk about those. But it may be your one option you have available for being able to solve this problem. So how does that work, right? You can't just put an appliance on each end and have it, kind of proxy the traffic across. You have to have another network that can talk to each other that is on a unique subnet that you then put this appliance on, and that's how we do it. We basically put a Windows Server as a virtual appliance. You put one on your on-premises network. You connect it to the subnet that you want to stretch. You connect it to a second subnet, in this case I call it transit, that is routable across to Azure. And then you go and do the same thing on the Azure side. You create a Windows Server VM over there. You connect it to a subnet with the same, in this case, 192.168 address space. You connect it to a transit that is routable so that now these two appliances can talk to each other over those transit subnets. And then those appliances will be able to create a VXLAN tunnel that will go over your site-to-site, your layer 3 connection, your site-to-site, or even your express route connection to be able to essentially send that traffic back and forth for those two subnets. So that now VM6, if it wants to talk to the VM16 on the bottom, it'll think it's talking to a local IP because that IP will be on that appliance on the left side, but that appliance will send it across the VXLAN tunnel where it'll go to the right side and send it out. VM16 will think that that .4 address is local, but it's actually being essentially sent across. And that's how the extended network works. I do want to caveat, many cautions I'm going to put out there. It's always better to deploy new applications into a subnet that is existing in one location at a time, right? It's always better to re-IP a machine onto a subnet that is in one location at a time, if you have that option. You don't want to make this extended subnet your default way of deploying because it is introducing a lot of complexity, a lot of diagnosing, additional diagnosing you may have to do. I'll talk about all of the extra things you're going to have to do and be aware of when you do this. So if you can, it's better to not do an extended subnet. I just want to put that out there right away. Now, some of the properties of this extended network. You'll get about 700 megabits of throughput. This was in our testing with our VMs. If your VM is a little bit faster, you may get a little bit faster throughput out of it. But around in our testing, we got about 700 megabits. Now, if these are 2008 R2 applications that have been around for 10 years, they're probably deployed with 1 gigabit networking in mind. So 700 megabits is probably in line with what they're expecting anyway. You can only extend 250 IP addresses across. Partly because we have to put every IP that's on premises as an IP on that VM in Azure, and Azure only supports about 250 IP addresses on a single network adapter. So that's another scale limit that you have to be aware of. We do require that layer 3 connectivity to already be established. So it can either be site-to-site, or if you do have ExpressRoute, we'll utilize that full ExpressRoute connection to send that VXLAN tunnel traffic over that ExpressRoute connection. You have to have those 2 network connections. When you do create the VMs on premises and in Azure, you have to have that second network for transiting, as well as the network that you're extending. VXLAN will go over UDP port 4789. That's important. If you have a firewall in between Azure and on premises, as a lot of you do, you have to make sure that port is open and can go through both directions. Mention which VMs you have to have created. Hypervisor. We don't care what hypervisor you're on. You can be on Hyper-V. You can be on VMware on premises. That appliance can be anywhere. So if you have a VMware deployment, you can extend that network into Azure as well. The only thing you have to be cautious of, if it is an SDN deployment on premises, whether it's Windows Server SDN or if you are using NSX, you may have to take some extra steps in that SDN deployment in order to be able to add those addresses on from the Azure side so that that VM knows that it has addresses on it that it needs to send across. And then, of course, it's all managed through Windows Admin Center. That's where you'll set it up. That's where you'll download the agent that will get installed. That's how you'll install the agent. Admin Center makes it very easy, and that's what I'm going to show you in a minute. Now, here's the fine print. This is the part that, you've all been waiting for. One thing I didn't talk about is that your routing will be asymmetric, meaning your machines on each side are always going to go down to the local version of the subnet to get to their connection. It'll then, if it needs to go across the connection, get sent across to the VM on the other side. That VM, when it sends its response, is going to go to its default gateway, which will be its local gateway, and so it'll go back out on that local connection instead of back through the appliance. It'll then get sent across the site-to-site link, because that'll be routable to each side, and eventually on to its destination. So it works great, unless you have a firewall in between. Firewalls like to track state. And if they're looking at the TCP sequence number, they're going to see numbers are getting skipped. And by default, they'll generally get dropped. So there are a couple settings you have to configure in your firewall if it's sitting in between on your site-to-site connection. There's a setting called sequence number randomization. This was an old security protection. Back when the OS itself didn't randomize the sequence number, it would then go and change the sequence number and randomize it for you. You need to disable that. You need to also enable TCP state bypass, because if it is counting those sequence numbers and sees ones get skipped, well, you need to make sure it doesn't drop that traffic. Each firewall appliance will have a different way of doing this. These settings are actually the names that I believe Cisco ASA uses for those settings. So if you look it up in Cisco ASA, you'll find these. But I looked up for pfSense. They have a whole section on asymmetric routing. You can go in and enable these settings. It'll enable that asymmetric routing. If you do have a firewall, I also mentioned you have to have UDP port 4789 also opened up. You should also need to be aware that your MTU is going to be a little bit smaller, because we're doing encapsulation with VXLAN that takes adds a little bit of header on top, which may be in addition to the site-to-site header that's also added, or if ExpressRoute adds a header, your MTU will be a little smaller. So for TCP, generally not a problem, because it'll negotiate the MTU. But if you're using UDP or some other protocol that doesn't do any sort of negotiation, you may have a problem there. Broadcasts aren't going to broadcast, because broadcasts aren't supported in Azure. So if you are expecting to move your DHCP server into Azure, well, that's not going to work. So be aware of that. Azure reserves the first 3 addresses. So if you want to move your .3 machine over, that's not going to work. There's a big list here of things that you have to be aware of. They reserve the first address for the router of those 3. That is, one of those is the Azure Virtual Network router. If your machines are configured to use .254, for example, as some customers do as your router for your network, you're going to have to change that so that it uses the .1 instead. What else do we got? Of course, latency will be a little higher. That will depend on how much latency is added by your layer 3 connection, your site-to-site or express route. But the actual encapsulation of the VXLAN traffic really adds almost an insignificant amount of extra latency on top of that. It's really just the connection of the fact that you're going across a much greater distance is where that latency comes from. Of course, you have to have the appliances on each end. You have to keep them running, up and running. If one of those goes down, your connection will go down. And then, of course, as I mentioned, if you have SDN on-prem, you'll need to make sure that that SDN connection is aware of these IP addresses going across. So these are some of the considerations you have to take into account before you decide if this will meet your needs as a solution. All right, who wants to see it now in action? All right, let's go. All right, so this is how we're going to start. So there are a few things you have to do in advance before you jump into Windows Admin Center and set it up. We require you to create these two appliances first, these two VMs, the Windows Server on-premises and the Windows Server in Azure. And you have to do a few things in there. I have here a connection to those Windows servers. Up top in the top right corner, I have the one in Azure. You can see the 10.1.1.6 is my Azure IP that I'm connected to. You have to go and you have to create a vSwitch in the VM. Because we do the VXLAN encapsulation through a switch extension that's running in the OS. That's how we do the VXLAN encapsulation. So you have to enable Hyper-V, and you have to create a vSwitch for each of your network adapters in that VM. You then connect those vSwitches to the two subnets one that you're going to be extending, as well as the one that you're going to be using for communication. In this case, I call it management for the communication, but for VXLAN. And then the extended is the one that we're going to be extending. Okay. I've done basically the exact same configuration for my on-premises VM down here in the right corner. You can see this is a 10.0 machine. It's on-premises, and it's got an IP on the 192.168 subnet. That's the one that I'm going to be extending from on-premises as well. And I've done basically the exact same configuration there. Okay, let's get started here. So on the left side, you see the Azure, my Azure resource group. I've got my virtual connection, my L3 connection already established. This is a site-to-site tunnel. I've got a few VMs in there. One of them, I've got a Linux VM, a router as well that I was testing with, and a 2008 R2 server. You can see my subnets there. I've got the one for routing, a 192 subnet, as well as the gateway subnet. Here's my site-to-site connection. Now let's go into Admin Center and see that get set up. You're going to drive it through the appliance on Admin Center. But before you do that, you have to actually install the extension from the feed. So you do that by going to Extensions. Under Available Extensions, you'll see an entry for Azure Extended Network. We'll widen that up so you can actually see the name. Click on it and click Install. It'll just take a few seconds to install. Once you click there, Admin Center will reload to recognize that extension. And then you can click on the on-premises appliance, because that's how you're going to drive this setup. When you click on it, you're going to log into it. We don't depend on Active Directory or anything like that. You can log in using a local account. It has to be administrator, though, on that machine. And then once we do that, you'll connect in. And then if you expand your tools on the left, you'll see Azure Extended Network. Click on that, and this will give you the introduction page it's where you'll get started to set it up. So we'll maximize this so we can see the full settings. Click Setup. You get an overview wizard. On the next page, you'll see the link for downloading. You click on that, it'll give you a self-extracting exe. You got to run that self-extracting exe to get a cab file out. You have to click on the EULA as well. That will give you this extended network cab file that you'll then select and upload to your appliance. This will upload to both the on-premises appliance as well as the one in Azure. So it's now uploading. And now you're going to tell it which of the two subnets, because this VM has a connection to two subnets. We'll read those in. You tell it which of the ones you're going to use to actually extend. It'll prompt you to connect to Azure if you haven't already. And then it'll start asking information about the Azure side of your connection. What does your Azure subscription look like? Which resource group? And then finally, which virtual network? We'll start to pull in information as you're doing this, like, what location is it in? What is the subnet? Do we find the same subnet on the other side? Have you already configured that? And we give you the deep links. So we now collected a lot of information automatically about your on-premises VM. We need a similar set of information about the Azure side. Which VM do you want to use to actually extend the network there? So we're drilling in there as well. We want to make sure you only have one adapter there, so we make sure for routing, if you do have extra adapters. And then that's it. We'll click deploy. This is going to start a sequence of tasks now to go and both configure on-premises. It's going to install that agent on-premises. It's going to transfer it to Azure, install it in Azure. I believe it takes about 6 minutes to do the full thing. 6 minutes later. It'll come back, and when it's successful, you'll see this diagram that shows you now have everything configured on both sides. You have the connection between the two. It's now going to continue to refresh in some information about Azure. It's calling the Azure API to see, OK, have you configured anything over there yet? When it finishes, you'll have both lists will be empty. You still have to now go in and tell it which IPs on these two subnets you want to make available on the other side. We did build in the ability. It will go out and scan the network to see what addresses are there. You'll see that in a minute when I drop down the list. So you can choose from what it discovered. Of course, if it didn't discover the addresses, you can add addresses that weren't discovered as well. OK, so it's finished setting up. Now we can go and click on Add IPv4 addresses. So you'll have a section on top for which of the on-premises addresses. And these are all the ones that were discovered. This is actually running on my physical network at home. So it's going out and scanning. It's finding physical devices. It's finding VMs. It's finding all sorts of stuff. Here I'm clicking on the .4. That's actually a QNAP storage device. It's a physical appliance I have on my physical network at home. The .253 is one of my Wi-Fi access points. I can click on that if I want to, just to show that we really can't connect to anything. Now on the Azure side, I'm going to go and type in the address that I want to make available on Azure. This is connected. This is what the IP that 2008R2 VM has in Azure. And of course, if it didn't discover the address I want, I can add that as well just by typing it in, clicking Add. Yes, I'm also adding the 254. It's doing discovery on Azure as well by calling the Azure API. That takes a little longer, which is why I didn't use that to type in the 250. But you can see there that it actually discovered those as well. Click the OK button. Now it's going to run for a few seconds while it goes and updates the appliance. It's going to go talk to the appliance on each end. Admin Center isn't involved in the data path, so it's going to go and do this once. The agent that's on the appliances is going to be what's going to be maintaining the persistence. So even if the appliance reboots, it'll automatically reestablish that those IPs are available and extended. And so there we go. It already did the on-premise one. That one goes pretty fast. The Azure one takes a little longer because we go through the Azure APIs to set this up as well. And so it'll take a minute to refresh, but you'll see that 250 address will show up there. That's the one from Azure that we're going to make available to on-premises machines. And once that refreshes in, we'll then go and I'll show you that, that it actually works. So there it is. So that's it. It's now extended. Now, by the way, these VMs or machines on each side, they can be Linux, they can be Windows. We don't care what the operating system is. They can be physical devices I'm going to show you that you can connect to. We just go by the IP address now at this point. So now let's go back to Azure. We'll connect to that 2008R2 server. We're going to go in through the public IP on that machine. So that's how you know it's an Azure machine. So there it is. The public IP is that 52.151 address. You'll see that in the top right corner if you can read that. I'm going to do an IP config. We'll see that it does have that 192.168.1.250 address. So it is on the 192.168 subnet. You can see, though, that it is in Azure also by the fact that it's getting from Azure DNS its DNS suffix. But here I go. I'm pinging my .1.4 address. That 1.4 address is on premises. That's not in Azure, and it's on the same subnet. I'm going to go and connect to it through the browser. You can see that I do have internet connectivity. Your internet connection will go straight out to the internet and back again. So you're not actually using that cross-link to go out to the internet. So that's going straight out and back again using the public IP. And now I'm connecting to my on-premises device. You can see it's starting to get some of the information in. This is at the .4 address on the same subnet, and there it is. That's actually a physical appliance that I have on premises. I'm connecting to it from Azure. Since it is a file server, I'll just show that I can actually connect to it by its IP. There it is. I've actually extended, that subnet from Azure, from on-premises into Azure, and I can now move my 2008 R2 machine across. It still has the same level of connectivity that it did before. So that's the important thing. I showed you where to find the extension. I showed you, what the prerequisites were. I showed you how to set it up, and I showed you the end result. So it's all there, and it's ready to go, ready for all of you to use. If you tried to use it earlier this week, the agent wasn't there yet. It's now available, fully available for you to install. Go and try it out. As soon as this session ends, you're free to go and use it. Now, if this doesn't work for you, there are some additional options you can consider. One of the things that Azure has also been working on is working with Cisco on an implementation based on Lisp. Lisp is a protocol that uses a much similar method of extending subnets from on-premises into Azure. It encapsulates, you have a lot of the same caveats, but one of the key differences is that Lisp is integrated into the physical switch. So if you have the physical switch that you can go in and modify and it supports Lisp, you can use it to extend the network. And that will help you with the asymmetric routing problem, because now the physical switch and the appliance in Azure know, that this is an extended subnet, and it'll know when to go across the link and when to go to its default gateway. It also requires you to have what's called a location server or a mapping server that all the different routers go to find out where is your IP located. It's also more suitable if you actually have many different subnets or many different places that you want to extend these subnets to. You can extend it not just to one location, but you can extend it to another as well. So that's another case where it's suitable. Azure has lots of documentation on this. They've gone out and built it out to make sure it works. You can go to that GitHub link at github.com/Microsoft/Azure-Lisp. But again, this does require you to have physical switch access and the ability to configure those switches to support this capability as well. So let's recap real quick before we wrap it up. Start with your layer 3 connectivity. You can either do it by having a single machine connect to Azure, if that's all you need. Use site-to-site to give many-to-many for many different operating systems to connect across as well. And then use that layer 3 site-to-site or express route connection then to extend your network to stretch that subnet from on-premises into Azure, so that now you can start to do these migrations and get additional VMs into Azure that you couldn't have done before. Get it from the Windows Admin Center. It's available now. I should also mention there's no cost on top of your normal Windows Server licensing or whatever resources you're using in Azure for the actual extended network. Of course, you do have to. There is cost for the resources in Azure and your Windows Server licenses, but the extended network itself has no additional cost either. So I do want to mention that. And finally, if these don't meet your need, feel free to go and try out third-party products. Lisp is one example, but there may be others out there as well that you can use. So with that, I want to thank you all for coming this morning. I am around for questions until they kick me out, as well as I'll be in the booth later this afternoon, as well as tomorrow. If you go to the hub, go to the Windows Server networking section, feel free to ask about Azure Extended Network there. So thanks, everyone, for coming in. And